Welcome to another episode of AI Talks with Chris and Nita. This is a special episode on a special day.
It is.
Merry Christmas to all our listeners.
Merry Christmas.
2025 is upon us.
It is.
Today, we're taking a deep dive into something super relevant in the world of AI.
Okay.
Model evaluation metrics.
Right.
Ever wonder how we figure out if those fancy AI models are actually doing a good job?
Yeah.
Well, these metrics are our tools of the trade.
It's a bit like checking the reviews before you buy a new gadget, right?
Right.
You want to know if it lives up to the hype
For sure.
in the AI world?
Yeah.
These metrics give us a way to peek under the hood and see if a model is truly delivering.
Okay, I'm intrigued, but there's so many different AI models out there doing all sorts of things.
Sure.
Is there one magic metric that tells us everything we need to know?
That's where it gets interesting.
Okay.
There isn't a one-size-fits-all metric.
Okay.
The best way to evaluate a model really depends on what you're trying to achieve with it.
It's all about context.
Okay.
Think of it this way.
Okay.
You wouldn't judge a fish by its ability to climb a tree.
Right? Good point. So how do we even begin to make sense of all these different metrics?
Yeah.
Where do we start?
Let's start with a scenario.
Okay.
Imagine you're building a spam filter for your email.
Right.
You want to separate the junk from the important stuff.
Yeah.
That's a classic example of what we call a classification problem. The model is trying to classify each email as either spam or not spam.
Okay, I can see that. But how do we actually measure how well the spam filter is doing?
Yeah.
We need some way to score it, right?
Absolutely.
Okay.
And that's where the confusion matrix comes in.
Okay.
Think of it like a baseball umpire calling balls and strikes.
Okay.
The confusion matrix is like a scorecard, tracking the model's correct and incorrect calls.
Okay.
It tells us how many emails were correctly identified as spam, how many were correctly identified as not spam,
Right.
and crucially, where the model made mistakes. So it's not just about being right or wrong,
Right.
but about understanding the different ways the model can be right or wrong.
Exactly.
Okay.
The confusion matrix breaks it down into 4 categories.
Okay.
True positives, true negatives, false positives, and false negatives.
Okay, let's break that down. A true positive is when the spam filter correctly flags a spam email.
Yes.
A true negative is when it correctly lets a legitimate email through.
Right.
What about the false ones?
A false positive is like the umpire calling a strike when it was actually a ball. A good email gets mistakenly flagged as spam.
Right.
A false negative is the opposite,
Okay.
like a ball slipping past the umpire for a strike.
Right.
A spam email sneaks through undetected.
That's a great analogy.
Yeah.
So the confusion matrix gives us this raw data on the model's performance.
Right.
But then how do we go from there to actually saying, hey, this model's doing a good job,
Right.
or this one needs some work?
That's where all those specific metrics come in. They help us summarize the information from the confusion matrix in different ways, giving us different perspectives on the model's strengths and weaknesses.
Okay.
One of the simplest is accuracy,
Okay.
which just tells you what percentage of predictions were correct overall.
So if my spam filter correctly classifies 90% of emails,
Yeah,
it has an accuracy of 90%.
exactly.
Sounds straightforward enough.
It is.
Okay.
But accuracy alone can be misleading,
No.
especially when you're dealing with imbalanced data sets.
Okay.
Imagine a data set where only 1% of emails are actually spam.
Okay.
A naive model that simply predicts not spam for every email would have 99% accuracy.
Wow.
Technically correct, but not very helpful.
So it's possible to have high accuracy, but still have a model that's not really doing what we want it to do?
Exactly.
That's a bit of a trap.
It is,
Yeah.
and that's why we need to look beyond accuracy
Okay.
and consider other metrics that give us a more nuanced picture of the model's performance.
Right.
That's where precision and recall come in. They help us understand the different ways the model can be right or wrong, especially when dealing with situations like our spam filter example.
Okay, let's dig into precision and recall.
Yeah,
These sound important.
they are. Precision is all about minimizing those false positives.
Okay.
It tells you out of all the emails the model flagged as spam, how many were actually spam.
So high precision spam filter means we're not getting many false alarms.
Exactly.
Our inbox isn't getting clogged up with legitimate emails that were wrongly flagged.
Right.
Okay.
On the other hand, recall, sometimes
Okay.
called sensitivity, is about minimizing those false negatives.
Okay.
It tells you out of all the actual spam emails, how many did the model correctly catch?
So a high recall spam filter means very few spam emails are slipping through the net.
You got it.
So ideally, we want a spam filter with both high precision and high recall.
That's the goal.
Okay.
But often there's a trade-off.
Okay.
If you make the filter really strict to avoid false positives, you might end up missing some actual spam.
Right.
And if you make it really sensitive to catch all the spam, you might end up with more false positives.
It's a delicate balancing act.
Yeah.
I'm guessing there are metrics that help us find that sweet spot between precision and recall.
Absolutely.
You're right, finding that balance is key. So are there any metrics that help us navigate this precision recall trade-off?
Absolutely.
Okay.
That's where the F1 score comes in.
Okay.
It's a single metric that combines precision and recall, giving us a balanced view of the model's performance.
Okay.
Think of it as a compromise between being overly cautious and overly sensitive.
So a higher F1 score generally means the model is doing a better job at both minimizing false positives and catching those sneaky spam emails.
Precisely.
Okay.
It's a handy tool when you need a single number to represent the overall effectiveness of your model, especially in situations where both precision and recall are equally important.
Right.
But sometimes we need to go beyond just looking at individual predictions.
What do you mean?
Well, let's say you're not only interested in whether an email is spam or not,
Okay.
but also in how confident the model is in its prediction.
Okay.
That's where a metric like log loss comes in.
Uh-huh.
It measures how well the model's predicted probabilities align with the actual outcomes.
Okay, so log loss is all about how sure the model is of itself.
Exactly. It
yeah.
penalizes the model more heavily when it makes a wrong prediction with high confidence.
Okay.
So if your spam filter is 99% sure an email is spam,
Yeah.
but it turns out to be a crucial message from your boss,
Oh,
log loss will reflect that mistake more severely.
that makes sense.
Yeah.
You don't want your model being overconfident and making costly mistakes.
Yeah.
It's like someone who's always 100% sure they're right, even when they're clearly wrong.
A perfect analogy.
Okay.
Now, so far, we've been focusing on classification problems,
Right.
where the goal is to categorize things like spam or not spam.
Yeah.
But what if you're trying to predict a continuous value?
Well.
Something like the price of a house.
So instead of categories, we're dealing with a range of numbers.
Right.
That sounds like a different challenge altogether.
It is.
Yeah.
And that's where we move into the realm of regression metrics.
Right.
Instead of asking, is this email spam?
Right.
We're asking, how much will this house sell for?
Okay, I'm following. So what kind of metrics do we use when we're trying to predict a number instead of a category?
One of the most straightforward ones is mean absolute error,
Okay.
or MAE.
MAE.
It simply measures the average difference between the model's predictions and the actual values.
So if my model predicts a house will sell for $500,000,
Yeah,
but it actually sells for $450,000.
right.
The error is $50,000.
Yes,
And MAE would average all those errors across all the houses the model's trying to predict.
exactly. It gives you a sense of how far off the mark your model's predictions tend to be on average.
Right.
But sometimes we want to be more sensitive to those really big errors.
I can see why that would be important, especially when dealing with something like house prices. A small error might not be a big deal, but a huge miscalculation could have serious consequences.
Absolutely.
Yeah.
And that's where root mean squared error, or RMSE, comes into play.
RMSE?
It's similar to MAE, but gives more weight to larger errors by squaring the differences before averaging them.
So if my model makes a few small errors and one massive one,
Yeah,
RMSE will really highlight that big miss.
precisely.
Got it.
It's like saying, hey, we need to pay attention to these outliers
Right.
because they could indicate a serious flaw in the model.
This is making a lot of sense. But how do we know if the model is actually capturing the underlying patterns in the data? Like, is it just making random guesses?
Yeah,
Or is it actually learning something meaningful about what drives house prices?
that's a great question.
Yeah.
And to answer that, we turn to metrics like R-squared.
R squared. Okay.
It tells you how much of the variation in the target variable,
Yeah.
in this case house prices,
Right.
is explained by the model.
So if R squared is high, it means the model is doing a good job of capturing the factors that influence house prices.
Exactly.
Okay.
But there's a catch.
Oh.
Regular R-squared can be a bit misleading because it doesn't account for the number of variables you're using in your model.
Okay.
You could throw in all sorts of irrelevant things, and R-squared might still go up.
So how do we avoid being fooled by a misleading R squared value?
We use a slightly modified version called adjusted R-squared.
Okay.
It penalizes you for adding more and more variables, giving you a more realistic assessment of how well the model is truly explaining the data.
Okay, adjusted R-squared is like a reality check, making sure we're not just adding complexity for the sake of it.
Exactly.
All right.
And beyond these commonly used metrics for regression, there are other valuable tools that provide unique insights into model performance.
Like what? Tell me more. I'm really curious to hear about these other tools. It feels like we're uncovering a whole toolbox for understanding how well AI models are working.
We are. For example, we have gain and lift charts, which are especially helpful when you're trying to target specific groups of people,
Right.
like in marketing campaigns. Imagine you're trying to predict which customers are most likely to respond to a certain offer.
So instead of just predicting whether someone will respond or not,
Yeah.
these charts help you see how much better your model is doing compared to just randomly guessing.
Exactly.
Okay.
They help you see if your model can effectively separate those who are likely to respond from those who aren't.
Got it.
And then there's the Kolmogorov-Smirnov statistic, or
Yeah.
KS statistic for short.
KS statistic. That sounds a bit intimidating.
It might sound complex,
Yeah.
but it's really about measuring how well your model can distinguish between two groups.
Okay.
Let's say you're building a credit risk model to predict who's likely to default on a loan.
Right.
The KS statistic would tell you how effectively your model separates those who are high risk from those who are low risk.
So a higher KS statistic means the model is doing a better job of drawing that line between the two groups.
Okay, it gives you a sense of how good the model is at discriminating between different classes.
Right.
And finally, we have the concordant-discordant ratio.
Okay, another intriguing name.
Right.
What does this ratio tell us?
It's all about consistency in ranking.
Okay.
Imagine you're ranking students based on their exam scores. The concordant-discordant ratio tells you how often the model correctly predicts the order of two students, meaning it puts the student with the higher score higher in the ranking.
So it's not just about getting individual predictions right,
Right.
but about getting the overall order correct.
Exactly.
Like
It's a measure of how well the model understands the relative relationships between different data points.
This is all fascinating stuff.
Yeah.
But before we get carried away with all these metrics, there's one thing that keeps coming up in our source material.
Yeah.
Cross-validation. Why is it so important?
Cross-validation is like giving your model a pop quiz
Okay.
to make sure it didn't just memorize the answers to the practice test. It's all about making sure your model can generalize to new unseen data.
So it's about making sure the model isn't just overfitting to the data it was trained on,
Right.
like a student who aces the practice test but then bombs the real exam.
A perfect analogy.
Right.
Cross-validation helps you avoid those nasty surprises by testing your model on multiple different subsets of your data.
It's like giving the model different perspectives to learn from,
Uh-huh.
so it doesn't get too fixated on just one view of the
Yeah,
data.
exactly. And that's crucial for building models that can actually be useful in the real world.
This whole deep dive has been incredibly eye-opening. I feel like I've gained a superpower,
Yeah.
the ability to see through the hype and understand how AI models are really performing.
And the best part is you don't need to be a data scientist to understand these concepts. With a little bit of knowledge, anyone can start asking the right questions and evaluating AI models with a critical eye.
So as we wrap up this deep dive, what's the key takeaway for our listeners? What do we want them to remember as they head into the new year?
Remember, when you hear about an amazing new AI model, don't just accept the claims at face value.
Right.
Ask how it was evaluated,
Right.
what metrics were used, and whether cross-validation was performed. This will give you a much deeper understanding of the model's true capabilities and limitations.
It's about being an informed consumer of AI, right?
Exactly.
We don't have to blindly trust the claims. We can understand the evidence ourselves.
Exactly. And with that, I think we've given our listeners plenty to ponder as we head into 2025.
A big thank you to all our listeners for joining us on this deep dive. From Chris and Nita, we wish you all a happy and insightful new year.